Hey, welcome back. Good to see you again. Thanks for joining the bench. Hope you're all well. So today on the bench I have a kitchen appliance, and you probably said, Trevor, do you fix kitchen appliances? Yeah, I have to fix these because I have a customer that is first priority, and yeah, they like to have their stuff fixed. So I was cooking ginger beef the other day, and I had a pot of rice on the background there cooking with it, and it got about 3/4 of the way through the cook cycle. And then I noticed the lights went out. And I was like, what? Because when you're cooking, this red light comes on. And then when it's done, the switch clicks off and this orange light illuminates to keep warm. So I was halfway or 3/4 of the way through the cooking the pot of rice, clicked off, and I was like, what the hell? So I just let it go. It finished cooking. There was enough residual heat in there to finish that pot of rice, so it was fine. But I took this and I was playing with it. And if you plug it in, there is nothing, completely dead. So I have a good feeling I know what it is already. So let's have a look at this thing. So it's got this aluminum disc here. It's kind of concave or convex. I can't remember the difference between the two. But this is your heating element, and this makes contact with the pot. There's an aluminum pot that sits in here that you fill up with rice. It's got a Teflon coating so it doesn't stick. Add your rice, wash your rice first, add your water, put the pot in here, put the lid on it, press the button and walk away. And then it does everything else. It's got this button here. I don't know if you've ever seen these before, but they have like a mechanical button. That's to sense if the pot's in place. If you remove the pot, then I think it switches off, just so that it doesn't burn out the element. So it's branded as Salton, Canada. It's a model RC200, made in China, and it's supposed to draw 700 watts. But as you saw from the test, we did drawing 0. So let's open this up and see. Two screws. And let's get to see what's in this. I've never looked in this before. Okay. So a little bit involved. We have our power coming in here. Comes in on this terminal block. And then it goes through this to, this is, I'm assuming, is a heating element. There's 2 connections for this. It's protruding out of the aluminum base here, so that's your heating element. And then it goes through to this thing and through to the switch. Now I think this is the dropping resistor for the warm cycle. And there's a switch here. When I click the switch, that's cooked there, and that feeds current through to there from here. And then when it's in the warm cycle, it opens this link and it's flowing through the resistor. Okay, so we have a high and low. Okay, so the switch is, I'm assuming the switch is fine. Let's get our meter out and start checking. So we got continuity mode. Let's check our power cord first. Okay, that one's good. That one's good. Let's check our heating element. The heating element's showing about 21 ohms, which is fine. What is this here? This is open. Is this a fusible link? There's no continuity between the line cord and this. I'm assuming that's a thermal fuse. Let's take this off and have a look. Got a nut on this end. Okay. I'm much you want to bet it's a thermal fuse. And it is. There it comes. Alright, so what do we have here? We have, if you can read this, it says 192 degrees Celsius, 10 amp, 250 volts. And this thing is open. Pretty sure it's open. Got nothing. Nothing. And our switch, let's see, between here and here. Okay, our switch is working. And resistor, what does that measure? Between here and here measures 265 ohms. So that's a fairly high resistance. I don't know how many watts that is, but it looks like it's been getting hot. And that drops the current through the heating element to keep it warm. Okay, so we need to replace our fuse. So I went out on AliExpress and bought this kit of thermal fuses, different values, different temperatures, because I have thermal fuses here, but I have limited stock on some values and no stock on others. So you can get these. This was only like 10 bucks, and I can't remember, there's like 50 or more or 70 different fuses in here, or I don't know how many values they have. So we need a 192. I think this is a 192. No, that's 105. Let's just look through this quickly. I don't see 192. Here we go. I think this is 192. And if I pull it out, yeah, 192. I don't know if you can read that. I'll roll it. So there's the branding, temperature 192, and then it's got 10 amps, 250 volts. Okay, so this is what we want. And we want to put ring terminals on it, because that's how we're going to connect it to the terminals. So now you can do one of two things. You can reuse these ring terminals. You have to open them up and recrimp them. These are brass though. I'm going to get some other ring terminals, some new ones. We'll see if we can make this work. I'm just going to get rid of these plastic bits because they're just in the way. Okay, so there's one. Okay, throw these away. And these are our new crimps. Now, why don't you just solder it? Well, you can't solder it because the temperature is involved, the solder will melt, and then the fuse falls apart like that. So we have to do this with crimps. So I don't have a crimper here. Maybe I do. Problem is these ring terminals. Well, let's see what we can do with this. We'll try crimping it manually. Okay, got it started. Okay. It's still loose. It's got to be tight, otherwise the joint's gonna have high resistance, and then you're gonna have heat. So let's try this. Let's pinch it. Pinch it in two spots. Pinch it there, and pinch it here. Okay, that's good. Okay, let's get the other side. I wanted about the same length too, so let's cut some of this off. And we'll put a ring terminal on this side as well. This die didn't turn out as good. Alright, let's crimp it. 2 spots. There. If you can see that. It's got to be tight. Both of them are tight. Give it a little extra squeeze just for good measure. Squeeze too much, you'll cut it off, but I don't want to do that. Good. We have continuity. Yep. Alright, so let's put this in. Let's cover it with some insulation. This is a silicone tubing wrapped with a kind of a fiberglass mesh, and it's fire resistant, so that's why they use it. So let's put this on just to protect it. There. Alright, let's install that. Alright, so we got our fuse, let's reinstall it. Let's see here. I think let's try this first. Come on. Alright. And then make the connection here. Now I don't see any reason why that previous fuse blew. I don't see overheating on any of these 2 joints. Let's just, let me get this, back this off and turn this. There, that looks better. Like I said, I don't see any overheating on these two joints here. Usually if you have one or the other joint loose, you get high resistance, and that high resistance, when you start putting current through it, then that turns it into heat, and you get a localized heating, and the heat will travel up the wire and blow the fuse. That's the operation of that. But that's back in place, and it's below the cover. So we put the cover back on. It's not touching, so it's not going to short out and create a ground fault. And that should be good. And we should have operation back. Now, I want to draw your attention to this. Look at the difference between these two. You see how this one is still transparent? It's a transparent jacket over the spade connector. And then look at the one down below. It's all burnt and black. It's because we have a high resistance here, and we're getting burning or heat. So let's pull this one off if we can. Let's get these out of the way here. Okay, pull this one off too. Ooh, that's tight. There we go. Yeah, that joint's been getting very hot. If you can see that, you can see the plating came off, and you can see bare copper. And this, let's cut this open. If I cut it open, yeah, I want to leave the jacket on there. The jacket's still there and it's working. What I want to do is get rid of the high resistance here. So what I want to do is I'm going to clean this contact. Let's remove that switch, just temporarily. If the switch is bad, we can replace that too, but I don't think that the switch is fine. Okay. You can see the oxidation on that terminal. This one here doesn't look bad, but this one here is really oxidized. Let me clean this up with some sandpaper and brighten this up, and I'll make a better connection. Just give me a minute. So what I did is I measured the contact resistance between here and here, and I was getting mixed results. I was getting a high resistance, but then when I moved the clip around, I was getting about 10 or 11 milliohms, which is good for the contacts, but the problem is the connection on the outside is poor. Here's the switch. If you ever need to replace a switch, you can see here's the ratings on it. It's 15 amp AC, 3 amp DC, 250 volts, and I think temperature 85 degrees Celsius max. Yeah, this is working. I'm not going to replace it, but you can see the oxidation on the one speed terminal there. So I'm just going to take a file and just going to clean off the oxidation. You can't see. Just going to clean this up. You see it's getting bright. It's better. Better than when it came in, so let's leave it at that. Now for this you can do one of two things. You can replace the spade connector, and I don't think I'm going to do that in this case. What I'm going to do is just going to recrimp the contacts. So if you look inside, you can see the electrical contacts, and I'm just going to squish them down a slight amount and crush this connector, and that'll bite into the terminal better than what it was. And let's just put this back on. It might be hard to force it on. There. And this one went up here. Actually, let's crimp this one as well, because the same current's flowing through it, both pins. Let's crimp this one a bit. Just crush these down. Get a better electrical contact. Push that on. Wow, okay. Reinstall our switch. Okay, now to test, we're going to plug it in. Let's see what it draws. 52 watts or so, and our light is on now. Turn it to cook. Heat goes up to 695 watts, which is correct. So it's working now. And those lights are working. Everything's good. So we'll close it up, and then we can cook rice again. I don't think I need to do anything else in here. We are golden. Let's put this Where is our mark here? How does this work? Okay. There we go. So why did it fail? It didn't seem, there's no overheating on this. It's not like it was exposed to anything crazy. I think it just, these fail with fatigue over time. And I think there's really nothing you can do about it. It's got a little thermal link inside. And you're putting 10 amps through it. Well, no, actually we were putting, I don't know what, I didn't measure it, but we measured it. And I forgot to take note. So, you got a dead appliance, look for a thermal fuse, and yeah, instead of throwing it in the garbage and running out and buy a new one, just get yourself some fuses. And well, there it is, simple fix, replacing a thermal fuse and a rice cooker. Not a very in-depth video, I know, and it's not very long and detailed, but we got our rice cooker cooking again. Maybe I'll celebrate by making a pot of sweet and sour chicken and steamed rice. But this is finished, so it's off the bench, and yeah, it was a short one, but thanks for watching anyway. Take care. See you later.